Is going to start. Okay, so let's start. So we are going to start the determination of Fourier series coefficient for the continuous time Fourier series periodic signal, right? So as we know that, uh, what are the different procedure adopting for the in order to find out or determine the coefficient of the Fourier series, very important. So you know xt. What is the xt? Xt is nothing but the summation of k is equals to minus infinite to infinite a k e to the power j k omega naught t. This is the Fourier series, right? This is the expression for the Fourier series, right? Now, now what we are doing in order to find out the coefficient, for the coefficient just to multiplying. See, it is very important. Okay, multiplying both sides by e to the power j n omega naught t, right? So when you multiply e to the power j n omega naught t, this is the second session, right? This is the second session of today at 11:30 a.m., right? So multiplying both sides by e to the power j n omega naught t, then we got xt e to the power j n omega naught t. See carefully, and if I will do any mistake, just to remind me. Okay, so this is a minus. So just to multiply xt with the e to the power minus j n omega naught t both side, so it becomes k is equals to minus infinite to infinite a k e to the power j k omega naught t into e to the power minus j n omega naught t, right? So now integrate both sides. Now integrating both sides for one period. Okay, for over a period, over a period, right? So when you integrate over a period, lunch for over a period, though it becomes xt to the power minus j n omega naught t summation, और ये हो जाएगा आपका when you integrate this one 0 to t over one period. So k is equals to minus infinite to infinite a k e to the power j k omega naught t into e to the power minus j n omega naught t, right? So now, just to with the help of the linearity property, due to the linearity property, you can apply this linearity property, and then you can exchange the, sorry, this is a dt, and here is also dt, e to the power minus j n omega naught t dt. So when you apply this linearity property, so due to the linearity property, you can exchange the summation with the integration. So it becomes k is equals to minus infinite to infinite a k, and then we take away the integration inside. So it becomes 0 to t e to the power j k minus n omega naught t dt, right? E to the power minus dt. So this is the one of the most important equation. Now we are going to solve this equation. Okay, so our target is to solve first of all this equation first, right? So in order to, I'm going to solve this integral. So for solving this equation, to evaluate the integral 0 to t e to the power j k minus n omega naught t dt. Okay, so we can write 0 to t e to the power j k minus n omega naught t dt equal to, in the polar form, it may be written as a 0 to t cos k minus n omega naught t plus j sin k minus n omega naught t, right, dt. So now 0 to t naught, or okay, we have written 0 to t or t naught. Okay, 0 to t, right? So 0 to t cos k minus n omega naught t plus j integration 0 to t sine k minus n omega naught t dt, right? So this is the case. Now, can anyone tell me what is the integration of cos k minus n omega naught t? Since cos k minus n or sine k minus n omega naught t dt is a periodic signal. Okay, this is the periodic signal with the fundamental period of t naught divided by k minus n. Okay, the fundamental period of this signal and this signal, the fundamental period may be determined t naught, or sorry, t, I have taken t, not t naught, t by k minus n. So can anybody tell me what is the integration of this term? Yes, anyone want to try? Students, Pranjul Dwivedi, do you want to solve this equation? Hello, it is not lunch time, bhai. Pranjul Dwivedi, huh? Gurvinder Singh.
Yes, sir.
Pranjul Dwivedi is not there. Can I mark absent?
Yes.
Okay, no problem. What is the roll number of Pranjul Dwivedi? Pranjul Dwivedi. Absent. Okay, no problem. Morning session he was also absent, and in this session this one. Lavis, can you tell me what is the solution of this integration?
Yes, sir.
What is the
Sir,
solution?
sine k minus n omega naught t
Uh,
divided by k minus n omega.
very good. Then आगे
Sir,
ठीक है,
plus j.
वो एक काम करके देखते हैं, राइट? लेट्स से दोनों का सेम ही होगा क्योंकि कॉस और साइन का बोथ आर द सेम सिग्नल है ना. तो कॉस के माइनस एन ओमेगा नॉट टी को हम इंटीग्रेट करके देख लेते हैं 0 टू टी डी टी को. सो यू आर सेइंग साइन के माइनस एन सर ओमेगा नॉट टी डिवाइडेड बाय के माइनस एन omega naught, right?
Yes,
0
sir.
to t. This is the case, right? Okay, thank you. So now when k is equals to n, there's a two case. Let's say when k is equals to n, अगर k is equals to n होगा तो क्या होगा और k is equals to n नहीं होगा तो क्या होगा? Okay, so first of all see when k is not equal to n. When k is not equal to n, then in that case, when you put t is equals to 2 pi by omega naught, right? Or omega naught is equals to 2 pi by t. So and in that case, the integration becomes k minus n omega naught 2 pi by t. Okay, k minus n omega naught 2 pi by t. Okay. This is the upper limit, and when you put the 0, so sine k minus n omega naught into 0 divided by k minus n omega naught. Okay, this is the upper limit, this is the lower limit, right? When k is not equal to n, when k is not equal to n, then this is the case cos k minus n omega naught t dt का ये इंटीग्रेशन आएगा, right? जब इसको सॉल्व करोगे तो it becomes 0 and it also becomes 0 because t is equals to 2 pi by omega naught है, जितना 2 pi by omega naught, right? So it is cancelled and sine 2 pi it is again 0. Sine 2 pi again make the equation 0. So finally when k is not equal to n, the integration term of 0 to t cos k minus n, right, omega naught t dt equal to 0. Same for the sine k minus n omega naught t dt, right? Same for the 0 to t sine k minus n omega naught t dt, right? Now, when k equal to, second case is when k equal to n. When k is equals to n, then what happen? Then can you tell me what will happen? How the integration will solve? Cos k minus
L
n.
hospital rule.
Very nice. Who is the gentleman? Pramod. Pramod ने बताया आंसर.
Yes, sir.
Okay, very good. So sin k minus n. तो एल हॉस्पिटल रूल किसके रेस्पेक्ट में करेंगे? यस,
K के respect में.
k के रेस्पेक्ट में. क्यों? क्योंकि k is the parameter which makes the this expression 0 by 0 form, right? K, when k equal to n, right? When k equal to n, then it becomes n minus n 0, n minus n 0. So it becomes 0 by 0 form. It's by 0 by 0 form. Therefore, we are applying L hospital rule. L hospital rule, right? We are applying L hospital with respect to k, right? So just integrate this one, then it becomes sine का क्या हो जाएगा जी? इंटीग्रेशन cos, है ना, k minus n omega naught t, right? And when you integrate this one, then we will got omega naught t. Am I right? Yes or no? ठीक है ना? बोलो भाई. Yes or no?
Yes, sir.
ठीक है? Okay? No. No. It is not correct. We will got cos, क्या हो जाएगा? k omega naught t ना? Cos k omega naught t, है ना? Yes or no? और ओमेगा नॉट टी डिवाइडेड बाय k के रिस्पेक्ट में करेंगे, तो विल ओनली गॉट ओमेगा नॉट. ठीक है ना?
Omega naught. Yes,
ठीक है
sir.
ना? तो 0 टू t, राइट? अब जब इसको 0 टू t पुट करोगे तो क्या आ जाएगा जरा बताओ? बट व्हेन यू पुट द 0 बाय t, सो अगर आप यहां पे पुट करें t, तो ये हो जाएगा ओमेगा नॉट t, राइट? ओमेगा नॉट t cos k ओमेगा नॉट 2 pi by t, 2 pi by omega naught, right? Omega naught cancel, or omega naught cancel, it gives t cos k 2 pi, or this value is 1, so it gives t, right? So for one period, it means when the value is, okay, it means when you integrate 0 to t or 0 to t naught, both are the same, right? When you integrate e to the power j k minus n omega naught dt, then you will got t naught when k is equals to n, and you got 0 when you will do k is not equal to n. Am I right? Is it any
Yes,
problem?
sir.
Is
सर
it
वैसे उसको स्टैंडर्ड साइन के फंक्शन से भी सॉल्व कर सकते थे. लिमिट्स का दैट साइन एक्स अपॉन एक्स फॉर्म में उसको कन्वर्ट करके फिर नीचे टी से मल्टीप्लाई, ऊपर से टी से मल्टीप्लाई, लास्ट में टी बचता, फिर टी माइनस 0 टी.
एल हॉस्पिटल रूल वो भी है सेम. sin x by x, sin x by x is again limit problem, that is
Yes,
again L hospital rule. Both are the same,
but
right? No
वो
problem.
स्ट्रेट अवे हो जाता लेकिन.
Yes. Okay,
Okay,
thank you.
sir.
So तो हम लोगों ने क्या किया? Now we have the final equation for the, we have the integral solution of this main equation. Now we are going to put this this solution into the main equation. Okay, the main equation was 0 to t naught or t, both are the same. I am writing t naught because generally book is writing taking the one period t naught, right? So xt e to the power minus j n omega naught t dt, right, is equals to summation of k is equals to minus infinite to infinite ak, and the integration was 0 to t naught e to the power j k minus n omega naught t dt, right? These are the things. So the integration of this equation, integration of this term, we know. So it will be when k is equals to n, then it becomes an, okay, summation of an, और इसका क्या आया, इसका आया t naught, इसका आ गया t naught, right? So t naught, so then 0 to t naught xt, हाँ जी sir, it is a minus j n omega naught t dt, right? So the value of an, the value of n, that is the Fourier coefficient, is nothing but the 1 upon t naught, okay, the division of t naught, the one time period, okay, over the one period of integration of xt to the power minus jn omega naught t dt. So this is the Fourier series coefficient derivation. Okay, you can find out the Fourier series coefficient derivation of this, from this equation, right? Any problem? Any problem? So finally, the Fourier series is represented in the form of xt is equals to what? Summation of k is equals to minus infinite to infinite ak e to the power minus j k omega naught t, with ak is equals to what? 1 upon t naught 0 to t naught xt e to the power minus j n omega naught t dt. This is the case. Any problem? Just see. Okay. एक बार आप लोग देख लो, अगर कोई प्रॉब्लम है तो मुझे बताओ, ठीक है? तब तक आप इसको दोबारा से आप इसको देख लो. Okay. जो कभी ऐसे को, ठीक है ना? मैं करता हूँ. Okay. So any problem up to this point, students? Please tell me. Any problem? Can we proceed further?
Yes, sir.
Okay, okay, okay. So we are moving towards further. Okay. So just see, this is the equation, the final equation. Let's say I'm representing this equation as A. Okay. So this omega naught is nothing but the fundamental frequency. This is the with 2 pi by T naught. Okay, where T naught is the fundamental period. Period. Okay, and omega naught is the fundamental frequency, right? Fundamental frequency, right? Now this equation A is very important. This equation A is very important for the analysis purpose. So how this, what is the कैसे एनालिसिस करना है हमें, देखिए हमें जो भी कोफिशिएंट आएगा, whatever the set of coefficient we got, okay, this coefficient is represented in this form, some in curly bracket AK, okay, and it is called Fourier series coefficient. In the exam, the question will ask, find out the Fourier series coefficient, some curly bracket AK, for the given problem, right? Or it is also known as a spectral coefficient. Okay, a spectral coefficient, we will see from the example, coefficient of signal, x of t. Okay, so how it is important, see, okay, one more thing, if when k is equals to n, okay, the coefficient a naught, the a naught क्या है आपका, a naught is nothing but the 1 by 2 t over a one period, okay, simply xt dt से आप इसको find out कर सकते हैं, a naught, okay, a naught आप इसे find out कर लोगे, no problem, and it gives the simply the average value, it gives a simple average value or dc value of the xt over one period, t naught or whatever the t, right? अच्छा, अब आप देखिए एक न्यूमेरिकल जिससे हम a1 और a1 minus 1 कैसे कोफिशिएंट फाइंड आउट करते हैं, राइट? तो एक सिंपल एग्जांपल आई एम टेकिंग a one very simple example so that you can find out. Let's say I have taken determine the Fourier series coefficient of a continuous time periodic signal xt is equals to, let's say, xt is equals to cos omega naught t, okay, where omega naught t is the fundamental frequency, right? So we have to find out the Fourier series coefficient for this. It is very simple example, right? So as we know that AK is one of the approaches, this one by T naught, okay, over T naught. Just we have to integrate by this equation and we will find out the AK, okay. Another approach is very simple. We can find out with the help of this equation also. But another approach is, see, we can write xt is equals to cos omega naught t, and cos omega naught t may be written like this one, e to the power j omega naught t plus e to the power minus j omega naught t divided by 2, right? This is the Euler relation. This is what? This is the Euler, you can say Euler equation, Euler relation, right? So it 1 by 2 e to the power j omega naught t, okay, and x, what is the Fourier series? Fourier series says summation of k is equals to minus infinite to infinite a k e to the power j k omega naught t dt, right? E to the power k j omega. What is this? When you expand this equation, then you can write a naught plus a1 e to the power j omega naught t plus a2 e to the power j2 omega naught t and so on. And this side a minus 1 e to the power minus j omega naught t plus a minus 2 e to the power minus j2 omega naught t and so on, right? So can you tell me, here the a naught is 0, a1 is e to the power j omega naught t, So it is 1 by 2 e to the power j omega naught t plus 1 by 2 e to the power minus j omega naught t, right? So it is a 1 by 2 e to the power j omega naught t and 1 by 2 e to the power minus j omega naught t, right? So this is the equation. So you can say here that what is the value of a1? A1 is nothing but the 1 by 2 and a minus 1 is nothing but the 1 by 2. A0 is nothing but the 0 and a2, a minus 2 is 0 and all other coefficients are 0 except a1 and a minus 1. Is it any problem? Please ask. Is it any problem? Students?
No, sir.
हाँ? कोई भी प्रॉब्लम है तो बताओ मैं. ठीक है, आगे बढ़े. यस, शुक्ला जी आगे बढ़े हैं. बाकी लोग क्लास में है नहीं क्या?
Yes, sir.
Yes, sir.
हार्डी कहाँ है?
Yes, sir.
हार्डी
Yes, sir.
ठीक है, समझ में आ गया यहाँ तक? हाँ बाबा, अरे बाबा जी समझ में आया? बोलता ही नहीं सब है. Okay, next problem is the, let's say, just determine the Fourier series coefficient, a case of a continuous time periodic signal. Let's say xt is equals to 1 plus sine omega naught t plus 2 cos omega naught t plus cos 2 omega naught t plus pi by 4. Can anybody solve and find out the AK where omega naught is the fundamental frequency? Anyone who want to give the answer? Okay, see how it will be going to represent. It is very important. Why it is called a spectral, coefficient, right? The logic behind that is behind in the solution of this question, right? So see, xt is given as a 1 plus sine omega naught t plus 2 cos omega naught t plus cos 2 omega naught t plus pi by 4, right? So when you're going to solve this equation, sine omega naught t nothing but the e to the power j omega naught t minus e to the power minus j omega naught, sorry, e to the minus j omega naught t divided by 2j, right? Plus 2, what is the value of cos omega naught t? E to the power j omega naught t plus e to the power minus j omega naught t divided by 2, right? Plus when you take the cos 2 omega naught t plus pi by 4, then it may be the represented at e to the power j 2 omega naught t plus pi by 4 by t, right? Pi by 4 t. Okay, take here pi by 4 t, right? Plus e to the power minus j 2 omega naught
Sir, बस
t.
5/4 ही होगा ना?
Okay, sorry. Pi by 4 t, right? And plus pi by 4 t, right? Divided by 2. Okay. So it is nothing but, when you're going to solve this one, then 1 plus, अच्छा देखिए e to the power j omega naught t to the power j omega naught t, यहाँ भी है, तो it will give क्या, ये हो जाएगा 2 cancel 1, तो it will 1 and यहाँ से क्या मिला, यहाँ से मिला आपको divided by 1 by 2j, right? ये किसका कोफिशिएंट है? e to the power j omega naught t. Am I right? Any problem? e to the power j omega naught t का ये कोफिशिएंट है. In similar way, you can find out the coefficient of e to the power minus j omega naught t. Can anybody tell me what is the coefficient of e to the minus j omega naught t? Yes, girl side. Priya. Priya is there. Garima Sidana.
Yes, sir.
Yes. Priya, tell me.
1 plus 1 upon 2
1
is
plus
pi
1 plus
minus
1
1.
upon 2j. Garima, you want to correct?
Sir,
1
1
upon
minus 1 by 2.
1 minus 1 by 2j. Right. 1 minus 1 by 2j. E to the power minus j omega naught t. Okay. And e to the power 2 omega naught t. There's a coefficient of it e j omega, sorry, 2 omega naught t also. So you can find out 1 by 2 e to the power j pi by 4. Right. And in similar way, 1 by 2 e to the power minus j pi by 4. Right. The coefficient of what? This is a coefficient. This is a coefficient of e to the power minus j 2 omega naught t. Right. So based on this, just to now, what is the Fourier series? Fourier series nothing but the xt is equals to k is equals to minus infinite to infinite. क्या हो जाएगा बताइए? A k e to the power j k omega naught t. Right. So इसका क्या मतलब है? इसका मतलब क्लियर है कि a naught plus a1 e to the power j omega naught t plus a2 e to the power j2 omega naught t, है ना? यहां तक है देखिए, प्लस a minus 1 e to the power minus j omega naught t और a minus 2 e to the power minus j2 omega naught t. राइट. तो आपका कौन कौन सा कोफिशिएंट यहाँ पे गिवन है? ऑल द कोफिशिएंट इज गिवन है. कंपेयर दिस थिंग्स. So you got a naught is equals to nothing but the 1. Right. A naught is equals to nothing but the 1. However, the other coefficient a, what is the a1? Can anyone tell me what is the a1? Please. What is a1? Please. What is
Sir,
a1?
1 plus 1 upon 2j.
Very nice. 1 plus 1 upon 2j. Okay. And when you multiply j with the numerator and denominator, then you will got 1 minus 1 by 2j. Right. Okay. Okay. Now can you tell me what is the value of a minus 1? What is the value of a minus 1? A minus 1. Yes. A minus 1. Other student.
1 minus 1 upon 2j.
1 minus, very good. 1 minus 1 by 2j. So when you solve, Baba is here or absent? Absent? Okay. I am marking absent. Okay, so a minus 1 equals to 1 minus 1 by 2j, right? So when you multiply by j in numerator and denominator, it becomes 1 plus 1 by 2j, right? Now tell me what is the value of a2, students? And this answer will be given by Anurag. Anurag, tell me what is the value of a2? What is the value of a2?
सर a2 की वैल्यू होगी वो e की पावर j2 ओमेगा नॉट टी का कोफिशिएंट वो है, कहाँ लिखा था? हाँ सर 1/2 e की पावर j into pi by 4.
Very good. And how it will be written? E to the power j pi by 4. How
सर
it
वो
is?
cos
1 by yes. Cos pi by 4. Very good. Plus j
plus j sin pi by 4.
and pi by 4. Very good. And you know the value of cos pi by 4 and this already, you know. So
Yes,
when you solve this equation, then you got like this one, right? Okay, very good. Now tell me what is the value of a of minus 2 now. Last. A of minus 2 becomes 1 by 2 e to the power minus j pi by 4, right? So it will gives 1 by 2 cos pi by 4 minus j sin pi by 4, right? So it will gives the root 2 by 4, 1 minus j. Okay. So you are able to find out A naught, you are able to find out A1, A2, and A of minus 2. Right? Now, since these are the complex coefficient, here in this case, we got the Fourier series coefficient complex, complex coefficient in this case. Whereas in the first case, we have a real coefficient. Okay. So here AK is written in the form of real part of AK, and the J of imaginary part of the AK, right? So since the complex coefficient is written in this form, then obviously it has the two parts, the magnitude as well as the angle or phase, right? So the magnitude of Fourier series coefficient AKs are determined by, obviously this will gives the magnitude AK by the formula. You can apply this formula, real part of AK है ना, AK का square plus the imaginary part of the AK square, right? So this is the magnitude, and the phase also you can determine. The phase of AK are also determined by angle of AK is tan inverse imaginary part of AK, right? And the divided by the real part of the AK. So this will provide nothing, this will provide the magnitude spectrum. It is also known as magnitude, the representation, the graphical form, right? Representation in graphical form, right? Graphical form is known as magnitude spectrum, and magnitude spectrum is this one, and this one is known as phase spectrum, right? We will draw for the above equation, for the above problem, right? So okay, so the determination of the magnitude of A naught is already given, 1. This is the real problem, the real real number. However, A minus 1, the magnitude of A minus 1, can you tell me what is the value of A minus 1? A minus 1 is here 1 plus 1 by 2j, 1 plus 1 by 2j. Okay, so 1 plus 1 by 2j. So with applying this simply the equation, and we will got root under 5 by 4, and this is the root 5 by 2, and this will approximately equal to 118. In similar way, you can calculate the value of magnitude A1, and it is again 1 square plus 1 by 2 square. Okay, so it will give again 1.118. Similarly, you can calculate A2 and A minus 2. So for the A2, 2 by what is the A2? A2 is given root 2 by 4 1 plus j, right? Root 2 by 4. So it is root 2 by 4 square plus root 2 by 4 square, and it will gives 1 by 2, it is gives 0.5, right? Similarly, you can calculate for the A of minus 2. A of minus 2 again you can calculate. This is the minus होगा यहाँ पे, ठीक है? और यहाँ पर root 2 by 4 का square plus root 2 by 4 का square, and it will provide 0.5. Okay, so the magnitude spectrum just we are going to plot after the calculating the determination of phase spectrum. So now calculate the determination of phase spectrum or phase of Fourier series coefficient, right? So it is calculated with the help of formula, imaginary part of the AK, right, divided by the real part of the AK, right? So when you calculate A naught, so it is simply, it is the tan inverse imaginary part upon real part. So imaginary part is 0, real part is 1. So it will give the 0 degree, right? 0 degree. However, for the A1, you can calculate with the tan inverse imaginary part. Imaginary part of this is 1 by 2 and 1, right? So 1 by 2 is the imaginary part and real part is the 1. So 1 by 2 by 1. So it will give tan inverse 0.5 and it will provide approximately 26.565 degree. Similarly, A of minus 1 you can calculate. Okay, sorry. A minus 1 you can calculate. A minus 1 is this one. Sorry. In A1, this is the minus 1 by 2 there. Okay. So this is the minus 26. This is the minus 20. However, this is the A minus 1. It is the tan inverse 1 by 2 and 1. The imaginary part is 1 by 2. Real part is 1. So it is 26.565. In the case of angle of A minus 2, tan inverse imaginary part is root 2 by 4. Real part is minus root 2 by 4. So minus tan inverse 1. So it is minus 45 degree. However, in the case of a angle of A2, for the A2, this is the imaginary part is root 2 by 4. A real part is also root 2 by 4. It will give the tan 1. This is the tan inverse 1. This is the 45 degree. Now we are going to plot magnitude spectrum as well as the angle spectrum, right? So see, it is very, very carefully see. Let's see. Now I'm going to the magnitude spectrum. Right? Magnitude spectrum. So when you're going to draw the magnitude spectrum, okay. So for the 0 value, the first coefficient is 0, A1, A2, right? This is the A0, this is the A1, this is the A2. Similarly, A minus 1 and A minus 2. So A0 is 1, A0 is 1, okay, A0 is 1, A1 is 1.118, okay, this is the 1.0, this is the 1.118, A2 is 0.5, A2 is 0.5. In similar way, this is also 1.118, 1.118, and this is the 0.5. You can see from the numeric value as we have calculated here. 1.118, A minus 1, A1 is 118, 1.118, A2 is 0.5, and A of minus 2 is 0.5. Any problem? You can draw also here, right? You can also draw. This is the A naught. A naught is, what is A naught? A naught is 1. So just to put A1, right? This is the this one. This is, what is A minus 1? A minus 1 is 1.118. So 1.118. This is the 1. This is the 1.118. What is A1? A1 is the 1.118. This is the 1.118. This is the A1. This is A minus 1. What is the A2? A2 0.5. And A minus 2 is also 0.5. So it is 0.5 and it is 0.5. Any problem? Students? Any problem?
No, sir.
Okay. Now, can you draw the phase spectrum? Just you can calculate the phase spectrum also. Just you can plot the phase spectrum. The phase spectrum may be calculated, may be drawn like this one. So A naught 0 degree. There is a 0 degree of A naught. So हमने 0 degree ले लिया. This is A naught के लिए है ये phase spectrum. However, A1 के लिए कितना है? -26. तो A1 के लिए हमने minus of 26 हमने दिखाया यहाँ पर. This is the minus 26.565 degree. This is the A1. A2 is the minus 45 degree. A2 is the 40 plus 45 degree. A2 is the plus 45 degree, right? This is the 45 degree. This is the A2. Whereas the A minus 1 is a 26 point, this 26.6, the 26.565. And however, A minus 2, this is the A minus 1, and A2 is nothing but the A minus 2 is nothing but the minus 45 degree. Minus 45 degree. Now tell me what is the this is the angle, okay, AK. This is the phase, okay, and this is the phase spectrum. However, in this case, we have plotted the magnitude, okay, magnitude, right, and this is the K. Other are the 0. So, magnitude spectrum is, the even. However, the phase spectrum is odd. You can say like this. Yes or no? आप देखिए
Yes, sir.
जो इसका आप मिरर इमेज देख सकते हैं आप, है ना, इवन और ऑड के टर्म में. यस और नो? बोलो भाई, यस और नो?
Yes, sir.
Okay. So you have to solve one problem as an assignment. Just to take the problem in one assignment, determine the Fourier series coefficient. Okay, this is an assignment problem, okay, of a continuous time periodic signal xt is equals to 1 from in between the minus t to t1 to t1, right, and 0 for mod t1 to t0 by 2, right. This is look like this. This is the minus of t1, this is the t1, this is the 0, okay, this is the t0 by 2, this is the minus t0 by 2, and then again the signal is t0, okay, and then like this, okay, and this is the minus of t0 and like this, right. So this is the case, and you have to determine the Fourier series coefficient for this one, okay. So this is as an assignment problem. This one is the assignment problem you have to solve, okay. Is it any problem? Now our next discussion is the convergence of Fourier series. Convergence of Fourier series, right? And we will discuss these things tomorrow, okay. We will discuss the convergence of Fourier series tomorrow, okay. So just try to solve this problem that I have given, okay. So till, thank you. If you want to ask any problem in between them, you can ask. I am just taking the attendance. Okay, Abhay Baba is absent. Achitya Bajaj, roll number 2. Bajaj absent. Achitya Bajaj absent. Aditya Kasture absent. Aditya Kumar,
Present, sir.
Aditya Saxena absent.
Present, sir.
Rawat.
Present, sir. Present, sir.
रावत आपका अटेंडेंस बहुत कम है और आदित्य सक्सेना आपका भी कम है. अनिशा
हेलो.
टोको, हाँ जी.
हेलो, प्रेजेंट सर.
Present, sir.
यस टोको.
सर, रोल नंबर 2 प्रेजेंट.
मनोज कुमार राय,
Present, sir.
अनुराग सोनी,
Present, sir.
अनुराग सोनी सुबह एब्सेंट थे। अर्शदीप,
प्रेजेंट सर।
अर्शजीत,
सर आदित्य कस्तूरी प्रेजेंट सर।
कितनी बार बोलेगा?
सर पिछली बोल नहीं पाया था, सर वाईफाई चला गया था।
आशुतोष शुक्ला, अस्की शुक्ला,
प्रेजेंट सर।
आशुतोष दुरेजा, दुरेजा, आशु त्रिपाठी,
प्रेजेंट सर।
त्रिपाठी, बबलू रानी,
प्रेजेंट सर।
बलवंत यादव,
प्रेजेंट सर।
भूपेन जोत,
यस सर।
गरिमा,
Present, sir.
सुबह एब्सेंट थे। स्वामी नायडू, स्वामी नायडू, गुरविंदर,
यस सर।
हार्डी,
यस सर।
हर्ष,
प्रेजेंट सर।
इंद्रदीप,
यस सर।
जसप्रीत,
प्रेजेंट सर।
जसविंदर,
प्रेजेंट सर।
जतिन।
प्रेजेंट सर। प्रेजेंट।
ओके ओके।